A proton collides with a stationary alpha particle. Man, a proton and an alpha particle, what's a proton? Well, you know what a proton is, right? It's that thing in the nucleus of the atom, whether you take chemistry or not. You've learned about protons in Science 9 and Science 10. You might forget details of it. You probably don't even know the mass of it. Where do you think you might find mass of it? Look at your data sheet, right? If it's not in a question, check your data sheet. Right? That's what it's for. Collides with an alpha particle, stationary alpha particle. What's an alpha particle? Well, you guys don't know what an alpha particle is, and you're not really going to know what an alpha particle is until Unit 4. It's a little nucleus. It's a little nucleus that forms as a result of radioactive decay. So it's got a couple protons and it's got a couple neutrons on it. You don't need to know any kind of details like that, because in the end, you can find the mass of this, whatever this cell particle is, on your data sheet. On the right-hand side, page 2 of your data sheet, right-hand side, scroll down and you can see the mass of the proton and the mass of the alpha particle, and a couple other things as well. After the proton moves at 3.35 times 10 to the 6 in the direction opposite to its initial motion. So if it was moving positive, now it's moving negative. If the proton was initially moving positive, then the alpha particle is now moving positive, and the proton is now moving negative, opposite to the way the proton was initially moving. Does that make sense, guys? Like, the wording of this is, I've always thought the wording of this was a little bit confusing, but I always put this on this practice quiz because this was a diploma exam question, and we have to be familiar with that wording, with working through wording of questions, right, and strategies for working through wording of questions. The initial speed of the proton is what? You know what I'm going to do? I should actually make a copy of this so we have a little bit more space to... All right, so what do we got here? I'm going to say mass 1. That's the mass of the proton. It's on our data sheet. It's 1.67 times 10 to the minus 27 kilograms. Do not memorize that number. Like, you got enough stuff to worry about that memorizing numbers, masses of protons, that's not one of them. Okay, check your data sheet for that. Okay, M2, the mass of the alpha particle, is 6.65 times 10 to the minus 27 kilograms. Don't memorize that either. Now, you guys, we use these numbers enough through the year that you might actually remember them by the end of what else we got here? We got a 3.35, negative 3.35 times 10 to the 6 meters per second. That's a velocity, of course. What velocity would it be? Would it be V1 or V2? 1 is the proton, 2 is the alpha particle. V1 or V2? John? Yep, yeah, it's V1. Good. It's V1. Is it V1 initial or is it V1 final? Proton collides with a stationary alpha particle. After the collision, the proton moves at 3.35. V1 initial, V1 final. This one is final, so it's going to be V1F. Now we get another velocity as well that's positive 2.25 times 10 to the 6. V2, yeah. Luke, is it V2I or V2F? Good, V2F. Excellent. The initial speed of the proton, we're looking for V1 initial. V1 initial, the initial velocity of the proton, which was object number 1. There is one more thing that I have here, if I read between the lines. What is it? V2 initial is what? Yeah, V2 initial is 0 meters per second. The alpha particle, it says before the collision, is at rest. All right, so let's do conservation of momentum for this. We're going to analyze the system. If we chose to analyze an object, which I would not conservation of momentum, PI equals PF. How many objects do we have before the collision here? 2. So we're going to say M1 V1I plus M2 V2I. Or I could just say, instead of saying M2 V2I, I could just say what? 0, right? Because that second object is at rest. It's okay, obviously it's okay to write in M2 V2I, but it's going to become 0 at some point. If you recognize it right now and you want to just pencil that in, that's fine. How many objects do we have after this collision takes place? 2. So let's say M1 V1F plus M2. Cancel a little bit to simplify here. You don't have to, by any means. Just makes it a little tighter, I guess. What could you cancel out here? What could you cancel? Yeah, I could cancel out exponents. I don't think I want to cancel out the 10 to the 6 for velocity because I'm looking for a velocity. So if I start canceling out the 10 to the 6 in velocities, I'm going to end up messing up in my answer, right? Like, I just don't want to go down that road. But for the masses, I could do that. Simplify things a little bit. Keeping in mind, you don't have to. Okay, just tidy it up a little bit if you do. Equals M1, 1.67 times 10 to the minus 27 kilograms times V1F. Whoops. Oh. I can't do it. I can't put it in one place and not put it in somewhere else, right? I've either got to cancel it or not cancel it. 1.67 times V1F is negative 3.35 times 10 to the minus 10 to the positive 6. M2 is 6.65 times V2F, which is 2.25 times 10 to the 6. It doesn't really matter to me what you do there. I got to be honest with you, the reason that I canceled it out there is because I don't have very much space there. If I can make it a little bit shorter, then it buys me some space on my page, right? Otherwise, there's not a whole lot of value in it. Let's get the right-hand side there. 1.67 times negative 3.35 times 10 to the 6. That's the first term. Plus 6.65 inside brackets times 2.25 times 10 to the 6. There's the right-hand side. Now let's divide that by 1.67. I don't really like doing that. I don't really like counting decimal places. I'm just going to switch this to scientific notation and multiply my answer by 1, and it's going to tell me that it's 5.61 times 10 to the 6. Now, the answer says 10 to the negative something here. I think I mentioned that to you yesterday, didn't I? That it should be a positive exponent. That won't happen on a test. Okay, if it says 10 to the negative something, it'll be 10 to the negative something if it's on a test. Test coming up not the first week back after our break. Which your test in a couple of weeks will be. How would we express it? Yeah, it would be 5616. So if you If you penciled that in wrong on your form when you submitted it last night, you get marked wrong. So what, right? Like it's just a practice thing, right? On test day, we don't want to submit that wrong. But I've mentioned this before. I think if on test day you have this done and you've written everything out like I have right here, and then including the answer 5.61 times 10 to the 6, and you pencil that in as 5616, you're allowed to ask me right in the middle of the test, like quietly, not out loud, for everybody to hear. But I don't want you to say, "Hey, is 5616 correct for number one?" Don't do that. But call me over and ask me. I'm not going to tell you if that's the right answer, but I'll absolutely tell you if you've expressed it right, and if it's bubbled in right. We don't want to lose marks on that, right? Good. Good. Okay. Anybody need time to copy that? No. Okay. Number 2. Let's make a copy of this one as well. All right, that's better. It says a clerk working at a local food store is asked to retrieve the empty shopping carts left outside by shoppers. Each cart has a mass of 20 kilograms. The clerk places 8 carts, which are locked together. So that's one object, right? 8 20-kilogram carts. That's a mass of 160 kilograms, right? In fact, I'm going to write that down right now. M1 is 160 kilograms. That's the 8 carts together. They're on a slight incline. The clerk gathers another 12 carts and pushes them toward the store entrance. That's going to be M2, which is 12 carts times 20, or 240 kilograms. Meanwhile, the first 8 carts roll toward the 12 carts with a speed of 2.3 meters per second. So, like the incline, guy pushing, whatever, that's before whatever we want to deal with here, right? Like we want immediately before and immediately after the collision so that we can have an isolated system. An isolated system for which there are no external forces, right? We don't want the slope. We don't want the guy pushing. We want just before, just after. But the 8 carts are moving before the collision at a speed of 2.3 meters per second. So I'm going to say V1 initial, that's the 8 carts initial, 2.3 meters per second. We're looking for the initial velocity, V2I, of the 12 carts. What else we got if we read between the lines here? There's something else that's important here. VF is what? 0. Yeah. Yep. VF is 0 because they all stop. Good. Everything comes to a stop. So good? So listen, when you see a question like 12 carts, 8 carts, incline, guy pushing, whatever, like just strip all that away. Turn this in to just a regular worksheet problem. Okay, we could rephrase this. 160 kilogram mass moving at 2.3 meters per second collides with a 240 kilogram mass. They come to a stop. What was the initial velocity of mass number 2? Right? That's the question. Don't get bogged down by wordings and 12 carts and 8 carts. Like, just make it simple. All right, so we're going to do PI equals PF here. Analyzing the system. We're going to say M1 V1I plus M2 V2I equals, how many objects do we have afterwards? 1. M total times VF, right? Or what else could we just write there? 0. Because everything stopped, right? Feel free to write an MT times VF. Right? But VF is 0, so eventually this term is going to become 0, whether we make it 0 now or later. All right, subbing in numbers here. M1 is 160 times V1I. M2 is 240 times V2I, that's what we're looking for, I guess, equals 0. Let's say 160 times 2.3. Oh, I'm going to be in scientific notation. I don't want to do that now. Let's go back to standard. 160 times 2.3 gives me a value of 368. Let's take that over to the other side by subtracting. Negative 368 divided by 240 gives me a value of negative 1.53. Now we're not actually looking for the velocity, we're looking for the speed, so the answer is just 1.53, the magnitude of the velocity, right? Good. I think we mentioned one day early on that when I look at that diploma exam that you guys don't have to write this year, when I look at it, I categorize them into category A, B, and C questions, or 1, 2, and 3 questions. 1 are, we got to be able to get this. Like this is a question that we should get. 2 is, we want to get these. They're very, very doable, but they become a little bit trickier. And then there's the category 3 questions where we still want to be able to get them, and we're going to work hard on them because we might be able to get 1 or 2 of them. But we also, there's no shame in missing it for sure if you miss the category 3 questions. I would put this in the lower end of a category 2. The wording of it's a bit tricky, right? The context of it is a little bit tricky. Mathematically, it's not that bad at all. I wouldn't make it a harder category 2 question at all, but I think I'd put it up into the category 2, where we want to get this right. But it's also not trivial. Okay, it's not just a trivial, really easy question either, just because of the wording of it. Are we good there? Okay, let's take a look at number 3 then. A 2,100 kilogram van collides with a 1,200 kilogram car that is at rest. They lock together. They move off at a speed of 4.5. What's the initial speed of the van? M1, the van. M2, the car. There's a velocity here of 4.5, 0 meters per second. What velocity would that be? V1, V2, V something else? Sorry? Just VF. Yeah, they lock together, right? What else do I have if I read between the lines here? Yeah, no, not V1I. V2I, right? 2,100 kilogram van moving collides with a car that's at rest. V2I is 0 meters per second. And we're looking for V1I, right? The initial velocity of the van. So this one's easier, I think. Pi equals PF. No change in direction. No crazy wording, I don't think, of this one. We're just going to say M1 V1I plus 0 equals mass total times VF. M1 is 1,200. V1I is what we're looking for. Total mass is, that should have been 2,100, right? That's 3,300 now, times VF, which is 4.5. Okay, we multiply those together, divide by 2,100. .07. And we don't even have to express this in scientific notation, right? We just bubble in 7.07 meters per second. What do you think we categorize this as, A, B, or C? Yeah, I'd make this an A, or category 1 question, right? Like, this is one that we want to get. Now, if you messed up on it for this, that's okay. This is practice, right? This is where if we're going to make mistakes, this is where we want to make mistakes, get them out of our system, learn from our mistakes. We're not, like, come unit test day, ideally we get this right now, right? But it's a process. Come unit test day, we definitely want to get this right. But we've got some time and some work to do still before unit test day as well. So if you got it wrong, don't panic. It doesn't mean you're in rough shape for this. Okay, it just means that you got a little bit of work to do. That's all, if you got this question wrong. Okay, and lastly, number 4, bumper cars operate on electricity. The more the accelerator is pressed, the more current flows in the system, thus the faster the car travels. They still don't travel very fast, right? You put it on the floor, and barely moves at all. They need to speed those things up, right? Like make it fun, speed them up a little bit. Yeah. Well, that's why you have a seatbelt that goes around your neck. You know those seatbelts those never seem very safe. Those seatbelts never seem very safe to me. I don't know. Whenever I go to an amusement park and I go on bumper cars, actually, I always end up like in more pain from getting bumped around if you're with friends that like to do head-on collisions and whatever. And I always find that harder than the rest of the rides. I don't know about you guys, but so probably a good idea that they can't speed up any faster than they are. But anyways, it says the more the accelerator is pressed, the more current flows in the system, faster the car travels. I'm not sure if that's completely true. X and Y are going to collide head-on. X is traveling at 2.25 meters per second to the east. Y is traveling at 1.30 meters per second to the west. So let's make it east and west, positive and negative. If after the collision Y is traveling at 0.526 to the east, what's the velocity of car X immediately after impact? Again, problem's not so hard. It's just the wording of it, right? Like the wordings are a little bit icky. Numbers all over the place. The east and the west as well, which we could easily make a mistake on. But I wish both masses were the same. I'm going to say mass 1 is 125 kilograms. I'm going to say mass 2 is 161 kilograms. Why do I wish both masses were the same? What would that do for me if they were the same? Yeah, we could cancel the mass then, right? Because the same mass would appear in every term. All right, what do we got here? We have 2.25 to the east, or positive 2.25 meters per second. What velocity would that be, Ashley? Is that V1 or V2, the 2.25? Yes. And is that V1I or V1F? Yes. The initial velocity of car number 1. Good? Okay. Let's take a look at the 1.3. That's a negative because it's to the west. Henry, is that going to be V1 or V2? Yes, good. And is that going to be V2I or V2F? Nope. It says car 1 collides with car 2, or car X collides with car Y, and then afterwards they're going at different speeds. That's going to be V2 initial, right? V2I. Make sense? And then it says after the collision, Y is moving at 0.526 to the east, so we're going to make that V2F, 0.526. And we're looking at V1F. Remember I said in these questions, the hardest part of this really is the givens, right? Once you get the givens written down, it's not too bad. Let's say M1 V1I plus M2 V2I equals M1 V1F plus M2 V2F. M1 is 125, V1I is 2.25. It gets a little ugly here. M2 is 161, V2I is negative 1.3. Don't forget that negative. M1 is 125 again. V1F is what we're looking for. M2 is 161. V2F is 0.526, positive 0.526. Holy, lots of numbers here. I put this up into category 2, I think, just because of the because of the amount of numbers that are there and the algebra that you've got to do, but also because of the positives and the negatives in there that we could easily mess up on. Okay, we don't want to mess up on that. We don't have to because it's not that hard, but we can easily do it. Let's get the left-hand side here. Let's get this. Let's say 120, let's use brackets here. 125 times 2.25 plus bracket 161 times negative 1.3. There's the left-hand side. Now I want to take this term over. How do I take that over? How do I take that term over to the left-hand side? Subtract it. Yeah, it's added to the right-hand side, so subtract it from the left-hand side. Subtract 161 times 0.526 equals. And then let's just divide by 125 now. Gives me 0.716. What? What did I do wrong? What did I do wrong? So what did I do? Where? Up here? Oh, right here? Oh, okay. So that should be 161 times 0.526. And then let's divide that by 125. That's still all right. Okay, let me just do this, okay? Bracket 125 times 2.25. Added to that is 161 times negative 1.3. And stop me if I make a mistake here, okay? Stop me like when I make it, as opposed to later on, so that we don't have to go through this process. Okay, 71.95. Subtract bracket 161 times 0.526. What did I do? Oh. Times 0.526. Yeah. Okay, divided by 125. There we go. Yeah, there we go. A's our answer there, right? We good there? Well, category 4, I guess that one is. Even though there's no such thing. That is definitely not a category 4. That's not even a category 3, right? Like, category 3s are hard ones. Like, we can make a mistake on this. It happens, right? But, like, the mistake isn't a result of, holy cow, what the heck is going on here, right? That's our category 3, the what the heck is going on here kind of questions. Okay? Now, this is not one of those. This is probably a 2. What, sorry? What about question number 1? I put that as a 2. Yeah. Yeah, because of the directions and so on, yeah. Yeah, like, just because, like, conservation of momentum, PI equals PF, is not that bad. But, like, there's things to trip us up in this question. And we don't want them to trip us up, and we can avoid it. Like, we can get good enough at this that we can avoid having those things trip us up. We can get good enough at this that we can get that question every single time, even though it's a category 2. Okay? And we're not writing off the category 3s either. We're not saying, like, oh, forget it, you're never going to get those. Not at all. We're just saying that if you get the category 1s and the category 2s correct, you can afford to get the odd category 3 wrong and still get a good mark, right? And if you get all the category 3s correct, good. Probably going to get 100 if you get all the category 3s correct, right? Good.